Hello. So in last lecture we have seen the nature of light, its various properties, then what is convex mirror, concave mirror, various type of lenses, total internal reflection, how the refraction occurs through the prism. Okay, all these we have seen, and then we have seen the refractive elements of eye, the cornea, interchamber, lens, vitreous, then retina. All these are the refractive elements, and the function of all these refractive elements is to focus the incoming light rays. Okay, onto the light sensitive part of the retina. That is fovea, and in fovea there are numerous rods and cones, and which convert this light energy into electrical impulses, and that impulses are carried to visual cortex via your various pathways. Okay, so this is the condition. Okay, so but this ideal condition usually do not exist. What happens? Ideally, what should happen? Light rays coming from the infinity, they should be focused on to the light sensitive part of the retina, but usually it do not happen. So what happens? So what happens? There, the light rays are focused either in front of the retina, or sometimes it may be focused behind the retina, or sometimes in one mirror they are focused on the retina. In other media they are either in front of the retina or behind the retina. So all these conditions in which the light incoming light is rays is not focused on the retina, it is the condition is called ametropia, or a condition of refractive error, which can be defined as a state of refraction wherein the parallel rays of light coming from infinity are focused either in front or behind the light sensitive layer of the retina. Hmm. Again, there are various types of refractive error or ametropia. Myopia, which is again most common, hypermetropia, astigmatism. These are different types of refractive errors. What is emetropia? So, emetropia is a condition of no refractive error. Means there the parallel rays of light are focused exactly on the fovea, or the light sensitive part of the retina. So, how this emetropization occurs? Emetropia is not there at birth. So at birth, what is there? Axial at birth, axial length is 18 millimeter. Cornea is more curved. Okay, interchamber is shallow, hmm, and there is hypermetropia of plus 2.5 diopter. And so as the child grows, there is this emetropization occurs. What happens? Axial length increases. Initially, at birth, cornea is more curved. So gradually the cornea flattens. Antechamber at birth is shallow. It becomes deepens. So at the age of around 8 to 10 years, this emetropia usually occurs. Okay, but sometimes this is not this is not a case. What happens? Sometimes this normal mark is overshooted, or sometimes this normal mark is not reached. Okay, or sometimes what happens? The corneal surface is not regular. Hmm? In all these conditions, refractive error occurs. So remember, emetropia is a condition of normal refractive error. Hmm? No refractive error. Sorry. Okay. Again, there are three types of metropia, as I've told you. Myopia, in which light rays are focused in front of the retina. Hypermetropia, these light rays are focused behind the retina. In astigmatism, what happens? Light rays are not do not come to point focus. Okay, in one media they are focused either behind the retina or in front of the retina. In other media they are focused elsewhere. So there is no point focus. The condition is called astigmatism. Okay, but the components of ametropia. When do this ametropia occurs? It can be due to corneal power. Okay, it can be due to changes in the axial length or the power of the crystalline lens. Hmm. So all these factors are responsible for the ametropia. These are called components of ametropia. So cornea, corneal power, interchamber depth, crystalline lens power, axial length. All these are the components of ametropia. Okay, and emetropization during the development of eye is the result of cooperation of all these components. Okay, so we will see first refractive error today, that is myopia. What do you mean by myopia? So in Greek, myon means to close and opia means to eye. So these people usually they prefer to see a closer object. Hmm? They see things blur, or the distant object is seen them to be a blur. That's why they are called myope. Okay. So what is the definition of myopia? It is defined as the dioptric condition of eye in which the parallel rays of light coming from infinity are focused in front of the light sensitive layer of the retina with the accommodation at rest. Okay, so this definition you have to remember. Light rays are focused in front of the retina. Okay, so how this occurs? Hmm? Think. So there are various components, as I have told you, components of ametropia. One is axial length, then corneal power, power of the lens, and the interchamber depth. So what changes do you think this will cause a excessive convergence of light rays, and that will be focused in front of the retina? So one is excessive length of the eyeball. Automatically, light rays will be converted in front of the retina. So that is called axial myopia. Next is curvature myopia. This is due to increased curvature of either cornea, lens, or both. Next is positional myopia. This positional myopia occurs when there is entire displacement of the lens in the eye. Usually, anterior chamber depth is, what is anterior chamber depth? It is a space between the posterior surface of cornea and your anterior surface of your lens. It is the anterior chamber depth. And it is usually 2.5 millimeter. Okay, 2.5 millimeter in the center. Huh? When this changes occurs in the anterior chamber depth, total power, the total effective power of the eye changes. Okay, when the anterior chamber depth decreases, total power will increase. When the anterior chamber depth increases, total power will decrease. Okay, so positional myopia occur when there is increased convergence power, and when this convergence power of eye will increase, when the cornea and the lens are placed close to each other. That is when 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 the anterior chamber depth either decreases or when there is anterior displacement of the lens. Next is index myopia. This is due to increased refractive index of crystalline lens. Okay, and when this occurs, as the age advances in old age patients or the old age individuals, there is sclerosis of the lens, and because of this sclerosis, the refractive index of the lens increases, and as the refractive index increases, the total power of the lens increases, and because of this increased power of the lens, total converging power of the eye will increase, and there will be excessive focusing or the excessive convergence of incoming light rays. So they are automatically they will be focused in front of the retina, and there will be a myopia. And fifth type is myopia due to excessive accommodation, or it is also called spurious myopia, in which there is excessive accommodation. In accommodation, what happens? As you know, there is contraction of the ciliary body. And ciliary body contains ciliary muscles. So there is excessive contraction of the ciliary muscles. It will relax the zonules, and because of the zonular relaxation, anterior surface of the lens, it will acquire more curved surface, and because of this more curved surface, total power of the lens will increase, and as the total power of the lens increases, automatically total effective power of the eye will increase, and again it will focus incoming light rays in front of the retina, leading to a myopia. But here it is called accommodative myopia or the spurious myopia, because theoretically, there is no any change in the cornea or lens. It occurs because of the excessive accommodation. So it is called spurious myopia. Hmm? Clinically, the myopia can be divided into different types again. Congenital myopia. First is congenital myopia. Second, simple myopia or developmental myopia, also called as a school myopia. Third one is pathological myopia or degenerative myopia. Okay. And fourth one is acquired myopia. Okay, so we will see one by one. First is congenital myopia. So congenital means it is present at birth. Usually, what happens at birth? At birth, child is usually hypermetropic. Remember, but what happens in congenital myopia? There is myopia at birth, but it is usually not diagnosed at the age. At that age, it is usually diagnosed after 2 to 3 years of age. And it is seen most frequently in premature babies, babies with birth defects such as Marfan syndrome, homocystinuria. And most of the times, what happens? This error is not bilateral. Most of the time, this error is unilateral, and which will lead to anisometropia. What What is anisometropia? Aniso, not same. Means refractive error in one eye is different and refractive error in other eye is different. Hmm? So one eye can be normal completely, or the other eye will have some refractive error. And when this difference is more than 3 diopter, we call it as a anisometropia. Okay. Okay. Next is all these. uh, this is all about congenital myopia. Okay. So error is usually 8 to 10 diopter in congenital myopia, and if it is unilateral, and it is usually unilateral, it leads to strabismus and amblyopia. What is strabismus? Strabismus means squint, and amblyopia means there is. We will learn what is amblyopia. Congenital myopia may be associated with other congenital anomalies like cataract, microphthalmus, aniridia, and management is early collection, early diagnosis, full correction or the early correction. Okay, and the correction here given is full cycloplegic refraction. Remember, cycloplegic. What is cycloplegic refraction? We will see later. Hmm? Usually, prognosis is poor. If the condition is bilateral, prognosis is good. If the condition is unilateral, it usually leads to strabismus and amblyopia. So, prognosis is poor in unilateral conditions. Remember. Next is simple myopia. It is called developmental myopia or school myopia. Huh? It is actually it is not any pathological condition. It is a physiological error. Okay, just a physiological error. Hmm? About 29% of the population have low simple myopia, low grade, that is less than 2 diopter. 7% have moderate myopia, that is 2 to 6 diopter. Okay, if you see the etiology of simple myopia, it is just a normal variation in the development of eye, which may or may not be genetically determined. Okay, inheritance is considered to be autosomal dominant, but in some reports claims that recessive mode inheritance is more common. Axial type of simple myopia may signify just a physiological error in the length of eyeball. Curvature type of simple myopia is considered to be due to underdevelopment of the eyeball. So remember, the most common type of myopia is axial myopia. Again, at any type of myopia, axial type of myopia is more common. Curvature type of myopia, the other less common. And if due to curvature, it is due to underdevelopment of the eyeball. Remember, Hmm. there are various theories being put forth for the explanation of this school myopia. And one of the theories is excessive near work. Okay, clinical picture. Hmm. So here remember, the children are not myopic at birth. Rather, the children are born hypermetropic at birth. And when the child grows, there is emmetroposition. Hmm? And at the age of 10 to 8 years, this emmetroposition should occur. But what happens as the development occurs? This normal mark is overshooted. So there is excessive increase in the axial length or excessive curvature of the cornea. So the normal mark is overshooted and it results in the myopia. Okay. So simple myopia usually begins at the age of 7 to 10 years and may increase during the years of growth until stabilizing around the mid-teens, usually at about minus 5 diopter. So error is usually less than 5 diopter and it never exceeds more than 8 diopter. Remember. What are the symptoms of simple myopia? Poor vision for distance, obviously. These children will have a poor vision for distance. Blurring of the distant vision. Okay. Asthenopic symptom. What's asthenopia? Asthenopia is a common term referring to your headache, broache, eye ache, okay, watering. So all these symptoms we combinedly call it as asthenopic symptoms. Hmm? And it is usually due to refractive errors. Okay. There may be a convergence weakness, exophoria. These are all symptoms. The most common symptoms are, remember, asthenopia and poor vision for the distance. What are the signs? Antechamber is usually deep. Remember, pupils are somewhat larger and bit sluggish. Fundus is normal, usually normal. Rarely some temporal crescent may be seen. Usually error is less than 6 diopter. Rarely it exceeds 8 diopter. Eyes may be large, prominent. Okay,